Alrighty, CNT125, we're working on Chapter 7 on network architecture. Here are the topics we're going to cover in this chapter, or the objectives here. A little bit about switches, a little bit about virtualization, a little bit about cloud characteristics, that sort of thing. Those will be the topics of Chapter 7. To start off with, they introduce or remind us the term networks architecture. This really is about the design, the devices that we're using on a network, how they're configured, how they're communicating with each other or outside of your network. That's your network's architecture. Now, the first topic in here, they talk about switches, so I'm going to remind us of a couple things we should hopefully remember from CNT120. Our connectivity devices will divide or segment a network. And our traditional switch that we talk about or think about is literally a layer 2 device. So this is going to kind of divide the network at layer 2. And we say layer 2 because switches typically read and interpret MAC address, layer 2 MAC address information. Remember, that's the address burned into our network card. The hexadecimal number that's burned into our network card that would identify our PC, our phone, our device on the network. So our switches typically will read and interpret MAC addresses. So they're going to maintain a table of MAC addresses and what MAC address is attached to what port. And it literally would be this port has this MAC address or these MAC addresses on, especially if you have 2 or 3 devices hooked up coming through that switch port. So it'll have a table of this port has this MAC address, this port has this MAC address. And the idea there is once it knows that, it will then be able to, when it receives a message, you know, when computer 1 goes to send a message into the switch goes, well, where are you going? Oh, you're going to computer 2? It literally sends it to 2 and only 2. 3 sends a message in saying, hey, going to 4, it's going to send to 4 and only to 4. So we now have a dedicated connection where the switch is trying to get information to one device and only one device based on that MAC address. And this is a big step in early networking. We went from the coax bus to hubs into switches. Hubs repeated everything to everybody. It was a big shared environment. Switches, reading the MAC addresses, are trying to send data to only one node. And because it's doing that, it can literally have simultaneous conversations going on, multiple conversations happening at one time, moving data through, giving us a lot better throughput and a lot better bandwidth on our devices. Here are a couple samples of switches, small port count, large port count, a chassis switch with multiple blades in and so forth. And these are all devices that are typically going to read that layer 2 address and try to direct the data to that single port that has that MAC address on. That's typically what's going to do. We also want to remember on switches that we do have our regular ports and our uplink ports. So if I look at these ports over here, these copper ports over here, if these ports are 100 meg, then the uplink ports on the right would typically be gig, basically a factor of 10 more. Because these uplink ports here, we typically use that to connect to another switch or another connectivity device. So it literally needs to have enough bandwidth to handle all of this traffic. So that's usually why it's like a factor of 10 more. If all of these ports are gig, then these here would need to be 10 gig ports to handle all of that traffic. Those uplink ports would need to be 10 gig to handle all that traffic. And these ports are typically SFP, small form pluggable. Right now it doesn't look like there's anything in there. I would buy an SFP module to slide in there to either give me a copper port or a fiber port. And I could be getting different SFPs for different types of fiber ports depending on the distance we need to connect these two devices together. If I were to bust open the switch, I typically find it's kind of like a specialized device that has, you have a power supply, you have a processor, and then you have all the network cards, if you will, and this is the fabric that's moving data between. I don't find the video, the mouse, and the keyboard port, and all. I don't have that. I basically have this as a device to move data in and out these ports. That's basically what I find here on our switch. So hopefully all of those things sound familiar. If not, I might have filled in a gap or two for you. As we start into the book now, they first start talking about types of switches. So the first type of switch they talk about is an unmanaged switch. This is a plug-and-play type device. Here, this is the kind of device that maybe a small business or maybe your house would use, where I plug this in. I literally plug my devices in, whether it be my desktop, my console, etc. And I really don't need to configure anything on here. There's really nothing to configure. It's just a connectivity device for you. That's your unmanaged switch. I don't configure anything. It's usually not expensive. The capabilities are not usually limited capabilities, kind of like connectivity. And it usually does not support anything like VLANs or any sort of advanced networking function, if you will. Meanwhile, a managed switch, the kind of thing you would find in a business or a school, this might have more ports. Sometimes it can have the same amount, but it usually has some more ports. But it also has some additional configuration capability. And now we might be in the $1,000 or a couple $1,000s for one of these switches as a price category. We will typically either console in, plug into it with a special cable and use command line to configure it, or we browse in using a graphical user interface and configure the device. And I will need to actually do some configuration on here to get this thing functioning the way I need it to in my network. I can sometimes do these as a group, sometimes I do them individually. When I'm done, I typically put an IP address on so I can get to this for management purposes. So I can browse into it later or communicate with it with my management station. That'd be your managed switch. And here'd be an example of browsing in to configure it. Here'd be an example of a configuration from a command prompt after I got done configuring the switch with things like VLANs and IP addresses and so forth. That'd be the command line interface way of doing that. Again, remembering a lot of our switches are layer 2, but there are switches that are layer 3 and layer 4. So most of the time when we talk switches, we're thinking layer 2. That's kind of our default. They do make layer 3 switches that are designed to interpret layer 3 data like a router. It would interpret IP addresses and move data around based on IP address. Now, it is still a switch. It does not have all the capabilities and functions of a router, but it can direct traffic like a router. So it's kind of like a router light, if you will. It's going to move data around like a router, but it's going to do a little faster, but it does not have all the features and capabilities. Sometimes the layer 3 switch gets used as the main switch in the building. Smaller switches in the building get connected to the layer 3, and it can handle moving traffic between the switches or between floors or between buildings kind of thing. There is also such a thing as a layer 4 switch that can interpret layer 4 data like TCP and UDP port numbers. So it can now start filtering based on the type of traffic that's trying to move through. This protocol, yes, allowed. This protocol, no. That's an application. We don't want that traffic moving through our network. And again, same thing. It does not have all the features, capabilities of routers and content filters and so forth, but it can at least do some basic filtering in our bigger picture. Switches, because we have lots of ports, we can actually do some port security. The reason being, remember, switches keep a MAC address table stored in their content addressable memory. It's temporary memory, if you will. And it literally has this port, has this MAC address on, this port has this MAC address on, and so forth. And again, traffic moves through the switch and goes, oh, you're going to that MAC address, I can put you out port 12 kind of thing and send you directly to that. Well, the switches can be subject to what's called MAC flooding, where a attacker sends a large number of messages to switch with different MAC addresses. It fills up the MAC address table, and then a lot of switches will default to, I'm just going to broadcast this out because I can't find it anywhere. I'm trying to go to this MAC address. I don't have it on my table anywhere. I broadcast it out. So now I've kind of defeated the intelligence of the switch, and it's broadcasting messages out everywhere and causing our network to bog down. That'd be a MAC flooding attack. Well, switches, you can do two things. The first line of defense is literally to shut down unused ports. So if I have switch ports that aren't being used, I shut them down. Those ports might be connected to, the switch ports might be connected to outlets in a hallway or lobby or rooms that aren't being used, or even ports in a room that aren't being used. I would shut those off so somebody cannot plug into them and gain access or move data in and out of my network. And many times I can just on my switch port do a command like no shutdown or shut down to turn it off. No shutdown will turn it back on. I know that's double negative land. English teachers cringe, but that's in computer world. Shutdown would be off, and no shutdown is the opposite, which would be on. I know, I didn't make this up. But that's one thing that can be done on switches. We will do that later this semester when we do one of our security chapters. We will shut down unused ports. If we shut down unused ports too early in our semester, we might be shutting down a port we're trying to use. So we'll do that a bit later, but that is one thing that can be done on a switch, shut down your unused ports. If I have a port shut off in my switch, it can indicate a couple different reasons why it's down. These are some of the different indicators I might see, the statuses I might see indicated. If it's administratively down, it would be us, the network admin, that shut it down. We used a command like shutdown to turn the port off. And next to it, if I do like a show and look at that port status, it would show that it's administratively down. It has been purposely shut down. It won't send or receive data. It's just like the light has been turned off, if you will. Again, we will do this later in our security chapter, later this semester in our security chapter. Another status I might get is an error disabled. If I have port security in a port, which we'll talk about in just a second, if I have port security on my switch port and a violation has occurred, maybe there's too many MAC addresses on that port, I can program that port to shut down. If that status gets met, too many MAC addresses on the port, it'll shut that port down and it will indicate error disabled, meaning this port has been disabled because of an error that's occurred. Again, we will do this in our security chapter. We will set up port security and we will push a bunch of MAC addresses through that port and have that port shut down. We'll actually see it shut down and we'll see the error disabled message. And the last status would be suspended. This might be a compatibility issue with another switch or another device. Maybe the two are configured identically and they're conflicting each other, so it goes into suspended status and will let us know maybe something on the other end is causing this issue. So those might be some status messages we might see on switch ports. That'd be your first line of defense. Shut that port down, unused ports down. The second one would be doing some switch port security. I can configure the switch port to shut down based on some type of event. In the case of our MAC flooding, I might program the switch port that if it starts receiving excess MAC addresses on that port, that it literally disables this port so it stops that flow of traffic into the switch that might overwhelm it and cause the switch to start broadcasting everywhere. And that can get done like so. And again, we will do this in our security chapter later this semester. We'll take a range of ports, we'll indicate port security, and we'll say, hey, that there should be a maximum 1 MAC address on here. And we indicate that the first one it sees, like when the switch boots up or the PC boots up, it holds on to it. And it will then indicate, hey, shut this port down if we get a violation, if we have a second MAC address show up on there. Second MAC address could be somebody tried to start up a virtual machine. That'd be a second MAC address. Somebody's trying to issue traffic, spoofing kind of thing. Maybe somebody unplugged the desktop and they're trying to plug their laptop in that port. A second MAC address would shut up and it would shut that port down. Okay, that could be a line of defense you use on your switch. And again, we will do that. We will do that in our security chapter later this semester. When we come back, we'll start talking about STP.